So last part of this section on trends is our time series decomposition. Um, basically the way you can kind of think of decomposition is like we're taking apart the time series into its different patterns. So like you might have a seasonal pattern, you have a different trend, and then you're kind of like left with like some of the noise, randomness, irregular parts, okay? And so this basically allows you to take those parts apart, and if you can imagine, if you can identify why there's a seasonality in this, why there's an upward trend in this way, this can really help you predict on like what the future will look like in a future time series and stuff like this, or identify those parts that are affecting those specific patterns. Okay. So just to kind of, I think the best way to do this is trying to show an example. Oh, before I move on though, this additive or multiplicative part that is mentioned in the curriculum, it kind of goes in a little bit of extra detail in this, but basically know that depending on what's going to happen to this time series, if you have an additive seasonality or multiplicative seasonality, you'll see a difference in what the time series looks like. So for example, is that an additive part, basically it just keeps increasing, increasing, increasing. You would see this increased upward trend, but for the most part, this, I should say like almost like, I wouldn't say like magnitude, basically that change in whatever your target is will stay about the same. So you can see here is that between the blue lines for each part, it doesn't really change in the size. However, multiplicative, you might have if it's multiplying, you'll have bigger and bigger upswings and bigger upswings and bigger, downswings. And you can see here is that it kind of expands outward. And hopefully that kind of makes sense of like they're going off of each other. They're being, in a sense, like multiplying off of each other. As you get bigger and bigger, these trends are getting larger, or these swings are getting larger and larger as well. So, yeah. So kind of showing an example of this, right? We have, and this is directly from the curriculum as well. So we have our passenger CSV. I believe this was supposed to be like about like airplanes. I can remember, I'm trying to remember exactly from the curriculum, but this is to show you a little toy example. And then we can see here basically our target here, and it's increasing, increasing, increasing. So first of all, looking at this based on what we have, would this be likely additive or multiplicative?
Additive.
Additive. And what makes you say additive, Adam?
I don't know. I just took a guess.
No, I appreciate it. Yeah. So you can see here a little bit is that the swing actually is getting larger and larger as we're going through time. So you would actually expect this to be a more multiplicative seasonality. So because we're basically getting this larger and larger swings up in here. Okay. So just a little check that we're saying, okay, what we expect this to look like.
Okay. It's a little additive too. More multiplicative, but it has some additive flavor.
That's true. You can see it kind of going up. So Adam, you've been approved by Aubrey.
Thank you.
You are most welcome.
All right. So now if you look at this, we can do now a log transformation on here, and we can see here, it's like now we can start getting those like the heteroscedasticity kind of going down a little bit. We can see that our swings are about the same now. We also have about linear. It was about linear before, but we can see that it's still pretty linear. Okay. And then we can actually use our stats models to basically do decomposition, right? So what's kind of cool is that with this decomposition method, the seasonal decompose, we can actually split it up into a trend, our seasonal, and a residual. And a residual is kind of like the leftovers, right? So if we actually plot this out, and again, this is from the curriculum as well, so you can kind of follow along with this way. You can see that we have the original guy right here, okay? And this is original meaning our original log transformation. So after we did log transformation, but our original here, we can see the trend. So you can see here's, oh, there's an upward trend, as we probably could tell from this image. We also see the seasonality. So the seasonality was kind of explained. And then this residual is basically like the stuff it couldn't classify as part of the seasonality in this trend, upward trend. So this is kind of the stuff that we really want. And then once you have this residuals part, you want to say, is this residuals actually stationary? So we can actually perform that test with the Dickey-Fuller, for example. And if we go ahead and roll through this guy, subtracting off our rolling mean, and then say, okay, let's check out Dickey-Fuller. We can see here basically from this point, like we talked about Dickey-Fuller last time, is we can see, oh, is it statistically significantly, what's it called, stationary? And we can see here our p-value is actually very, very small. So we're pretty confident that this is in fact stationary. Cool. All right. So any questions on any of this stuff before we kind of wrap it up? Cool. All right, so I'm gonna go ahead and stop it here.